Hello student, today we talk about improper integrals. So if we talk about what is improper integral, any definite integral like that we can write the definite integral like that a to b fx dx is called improper integral या हम कह सकते हैं improper या infinite integral if either any one or both limits are infinite and function is bounded over the interval or we can say neither the interval AB is finite nor function is bounded. Intervals AB is finite nor function is bounded over it. Okay. So what do you mean by improper integral? Any definite integral. Definite means that integral which have limits. Okay. Indefinite integral means which doesn't have any limit. Like simple integral. This is indefinite. Okay. But if we have some if we have some limit like that a to b, it may be infinite or it may be finite. Then it is definite integral. And we can say any definite integral is called improper yeah infinite integral if any one of the limit is infinite. Any one या both the limits मतलब एक या तो एक लिमिट फाइनाइट इनफाइनाइट हो या दोनों लिमिट इनफाइनाइट हो तब हमारा जो डेफिनेट इंटीग्रल है इम्प्रॉपर इंटीग्रल होगा. ओके. और इसके साथ ही हमारा जो फंक्शन है वो बाउंडेड होना चाहिए. बाउंडेड का मतलब क्या है कि उसकी कुछ बाउंड्रीज होनी चाहिए. मीन्स इस फंक्शन की वैल्यू इस वैल्यू से इस वैल्यू के बीच लाई कर रही है. दैट इज बाउंडेड. ओके. I think it is clear to you. So now we go for next part, which is types of improper integral. Mainly there are two types of improper integral. So now we go for types of या हम कह सकते हैं kinds of improper integral. So first one is improper integral of first kind. So in improper integral of first kind, uh, we can say a definite integral a to b fx dx, in which limits are infinite, that is either b is infinity or is infinity, and integrand is continuous. Yeah, we can say bounding. Is called improper integral of first kind. So, in improper integral of first kind, the limit is infinite and integrand is continuous, that is bounded. Then this type of integral is known as improper integral of first kind. And the improper integral of first kind also categorized into three categories. Improper integral of first kind is categorized into three categories. First one, upper limit infinite. For example, we can write if a lower limit is finite but upper limit is infinite and function is bounded. So this one is 1 upon 1 plus x squared dx. So if we see here, the upper limit is infinite and this function fx equals 1 upon 1 plus x squared is bounded. If we find the values between this interval and this function is bounded, because when you put the value 0 then you get 1, but when you put the value infinity then you get 0, means the value of this function is lies between 0 and 1. Okay, that means this function is bounded and uh, it is also continuous. And second one is lower limit infinite. It means if we have lower limit infinite like that, we have minus infinity to 1 and fx is like that 1 by x plus 1. Okay, so this is also improper integral of first kind. In the third case, when both the limit are infinite. So for both limit infinite, so we can take the example like that, minus infinity to infinity, 1 by 1 plus x squared. So this is all three categories of improper integral of first kind. I think it is clear to you. So first one, how we will find the value of improper integral of first kind. So now you can see here. Uh, First, when upper limit is infinite, so consider a to b fx dx. Here, fx is continuous in a to infinity. Okay, so there exists a definite number. You can write directly. We can solve it like that. A to this is e to infinity fx dx. So we will write like that limit b to infinity a to b fx dx. Okay, we can show one example like that. For example, we have an integral like that. First one, 1 to infinity dx upon x to the power 3 by 2. So here we see that upper limit is infinite and this function is bounded because its values lies between 0 and 1. So we can write like that limit b tending to infinity, and we can write 1 to b dx upon x to the power 3 by 2. So we can write like that limit b tends to infinity, and it can be written as x to the power minus 3 by 2 dx. Okay. Now we know that the integral rule is that if we have x to the power n, then its integral will be x to the power n plus 1 upon n plus 1. So here we have the power x to the power minus 3 by 2. So we can write like that minus 3 by 2 plus 1 upon minus 3 by 2 plus 1. Okay, and limit is that 1 to b. And also here limit b tending to infinity. So now we can write that limit b tending to infinity. And now we put the value. First we can simplify it, so it will come x to the power minus half upon minus half. Okay, and 1 to b. So we can write like that limit b tending to infinity. This 2 goes to upper side. So we can write 2, and this is square root of x. Okay, and the limit is 1 to b. Now we put the limit, then we get minus 2 upon under root b plus 2. And we put the limit of b, then we get minus 2 by square root of infinity plus 2. That is, it will come 2, which is finite and non-zero. Means integral exists finite and the given integral is convergent. The integral exists and finite. So we can say the given integral is convergent. So I think it is clear to you. For convergent to divergent, if this value is finite, then it is convergent. But if its value is plus infinity or minus infinity, then it is not convergent. The limit not coming unique, then it is not convergent. Now we go for another type, which is when lower limit is infinite. First of all, note one thing. If limit is finite, then improper integral a to infinity fx dx is convergent. Otherwise, divergent. Okay. Now we go for second category, which is when lower limit is infinite. So consider like that if we have minus infinity to b fx dx. Then we can write it like that, limit a tending to minus infinity a to b fx dx. Let us show one example like that. We have this one. Test the convergence of the integral. We have given this minus infinity to 0 sine hyperbolic dx. So first of all, you know how we can write hyperbolic functions like sine hyperbolic or cos hyperbolic. So there is a formula for sine hyperbolic x, which is e to the power x minus e to the power minus x by 2. And likewise, we have for cos hyperbolic x, e to the power x plus e to the power minus x by 2. Okay. So we will use this formula for this. So first of all, we see this is of second category. Here lower limit is infinite. Okay. So we can write it's like that, limit a tending to minus infinity a to 0 sine hyperbolic x dx. Okay. We can write like that. Now you can see here a limit a tending to minus infinity. We can put the value of sine hyperbolic here e to the power x minus e to the power minus x by 2 dx. Okay. Now we can take 1 by 2 h common and we can separate into two parts. First one is a to 0 e to the power x dx plus minus second one is limit a tends to minus infinity to the power minus x integral a to 0 e to the power minus x dx. Now we can integrate easily. So it will come 1 by 2 limit a tending to minus infinity. This one is e to the power x and limit is a to 0 minus this one is limit a tending to minus infinity. And the integration of e to the power minus x is minus of e to the power x and limit goes to a to 0. Now we put the value, then we get limit a tending to minus infinity, here e to the power 0 minus e to the power a minus limit a tending to minus infinity. This is minus e to the power 0 plus e to the power a e to the power minus. Now we put the value, so we get this one is 1 minus e to the power minus infinity, and here this is minus minus plus e to the power 0 and minus e to the power infinity. So it will come infinity. This is 0, this is 2. So it will come half of 2 minus infinity. So this is minus infinity. So that is the given integral is divergent. the given integral is divergent. I hope you get it. So we go for third part, which is when both the limits are infinite. So consider we have this one minus infinity to plus infinity fx dx. Okay, so we can break this one into parts like that minus infinity to a fx dx plus a to infinity fx dx. Okay, now here we apply the rule for when lower limit is infinite. Now we apply the rule for when upper limit is infinite. So we can write it like that limit a tending to minus infinity. Yeah, it is a, so we can take it b. B tending to minus infinity, so we can write b to a fx dx. Like we can say c to infinity, then we can write a to c fx dx. Okay, so if both the limits are finite, then the integral minus infinity to infinity fx dx is convergent. Otherwise divergent. If any one or both limits are infinite, if any one or both limits are infinite, then it is divergent. So now we take one example like that when both the limits is infinite. So how we can solve it? So let us take one example. We have test the convergence of integral minus infinity to plus infinity dx upon 1 plus x square. Solution देखो. We have minus infinity to plus infinity dx upon 1 plus x square. So first we can convert like that minus infinity to 0 dx upon 1 plus x square plus 0 to infinity dx upon 1 plus x square. Here the lower limit is infinite and here the upper limit is infinite. So we can use that concept. So we can write like that limit a tending to minus infinity and a to 0 dx upon 1 plus x square plus we can write like that limit b tending to infinity 0 to b dx upon 1 plus x square. So now we know that the integral of this is tan inverse x. So limit a tending to minus infinity tan inverse x and a to 0. This is limit and this is limit b tending to infinity and tan inverse x. This is 0 to b. Now we will put the value, so it will come tan inverse 0 minus tan inverse a plus limit b tending to infinity tan inverse b minus tan inverse 0. Okay, we know that tan inverse 0 is 0, so it will be 0 minus tan inverse a plus limit b tending to infinity tan inverse b minus tan inverse 0 is 0. Now we put the value of limit, so it will come minus of tan inverse minus infinity plus tan inverse infinity. We know that you can see tan of minus x. It will be minus of tan x. Okay, same rule for inverse. So it will be minus of plus infinity. So it will come tan inverse infinity the plus tan inverse infinity, and we know that tan inverse infinity is pi by 2. So it will come pi by 2 plus pi by 2, that is pi, and which is finite and unique. So we can say the given integral is convergent. Therefore, the given integral is convergent. Okay. So this is the process how we solve the improper integral of first kind. So in the second video we will discuss about improper integral of second. I hope you will understand